Inverse cosine is, so we're looking for a radian value that gets me 1 for a cosine value. 0. So you will take this and you will replace this entire highlighted part with 0. So when you rewrite it, it is sine of 0. What is the sine of 0?
Sine of 0 is
0. That is your answer. I'm going to do number 2 really fast. Now, since our interior part of our function is not inverse, we are looking at the radian value. So at pi halves, what is our sine value?
1.
You replace this entire thing with 1. So now we have the inverse cosine of 1, which is what? It's 0. How exciting.
Wait. How did we get 0 again? The inverse?
Inverse cosine, so you're looking for on the coordinate plane,
Yeah.
which of your coordinates for cosine, so all your x's, which of those is 1?
And then the sine is 0.
At pi halves, on your unit circle, what is the sine value? It's 1.
Yeah.
So you replace that entire inside function, which is why I rewrite my equations every time.
Okay.
So I need you to work on, and we should have probably already done this. We did some of these problems. These were the ones I highlighted and circled on Friday that we're going to be eligible to do. We're going to go back and do 4, 5, and 8. But you have 3 minutes to do 3, 6, and 7 with a buddy. Or multiple buddies. I don't care. As long as you're talking to somebody. For which
Okay,
one?
the inverse. So the
No, because it's on the.
It's the sine.
Yeah.
I'm looking at number 6.
David, you said I'm gonna start proving y'all wrong. David, you proved me right so far. David be lost.
To be honest, I don't even remember you.
So we do cos.
Well, alternates are posted, so I was
Cosine.
usually we've been given with the sign of pi clear.
Cosine of
When it's inverse, we are looking for where the cosine is equal to. So we can look at your
Yeah.
circle and say where is here.
3. And then that's.
So break down the radian value.
Then we don't do the cosine.
Wait, is this the thing where
You only got this side, right? So just break down
Sine of two.
sine.
is this thing where we do like quadrant 1, 2, and 1, 2?
Correct.
Okay,
So
I don't know the
again?
one.
So what, now this doesn't have a little inverse.
And then we negative pi.
Yeah.
Negative. We're just
For this one, the cosine of 5 pi 6, because you're given a radian, and it gives, so 5 pi 6, what is? Yes. So sine negative 4.
I gotta look at my notes.
Oh, wait. No, that's right.
I gotta know what to do.
Oh, you just have your little, oh, yeah, you have to keep your little negative 1. Yeah.
Number 6.
Question?
What do you do for tangent?
Tangent is 1 and 4.
I thought cosine was 1.
Sine is 1 and 4, cosine is 1 and 2, and I circled 3, 6, and 7 because it goes have to do,
Oh, so we're not doing tangent.
not right now, we're gonna go back to that.
Oh yeah, sine is 1.
I think it's 1 half. I think it's the one that says 2.
So inverse sine has a restricted domain, right?
Okay,
So we're looking at quadrants.
For number 5.
And so in 1 and 4, where is the sign equal to negative? But we rewrite that. Negative pi there. Okay, are we cool if we go over it?
Yes.
Yes, please.
Please. Only because you asked so nicely.
I'm feeling very confused.
So for number 3, we focus first on the inside part. It is asking us the inverse function of sine equal to negative root 3 over 2. So when it says the inverse function, we are dealing with the restricted domain, right? So what quadrant are we looking in if we have the restricted domain and we have a negative?
Negative pi halves to
Negative pi halves to positive
positive pi halves.
pi halves, which is in what 2 quadrants? Hold them up on your fingers. I need one on one hand and the other on the other. That was a lot of words. Okay, it's 1 and 4. Good. So in quadrant 4, where is the sine value equal to negative root 3 over 2? 5 pi over 3, which is equivalent to what?
Negative pi over 3.
Negative pi over 3. At negative pi over 3, what is the cosine value? 1/2. And that is your answer. So for all these, you got to break it down for yourself. Start on the inside, work your way out. Number 6, it is telling us that we have to go to 5 pi 6 and find the cosine value. Josiah, what is that cosine value? Where is the inverse function equal to negative root 3 over 2? We have this new equation. We have the sine, the inverse sine of negative root 3 over 2. Where is sine equal to negative root 3 over 2?
Is it negative pi over 3? Negative over 6. It's in quadrant 4, right?
Yep.
Okay.
Now, did anyone get to number 7?
No.
Is there anywhere on our unit circle where we can find number 2?
No. That's a big thing.
Wait.
No solution is different than DNE or undefined. Now, for those of you that were either testing, absent, what have you, on Friday we finished with the tangent function. So that means that we have already previously gone over the cosine and sine function. That was on Thursday. It is posted on YouTube for the 2-6 notes. But we're going to review the tangent one more time. So if tangent has a range of negative pi halves to pi halves, what 2 quadrants are we in? If it tells us that our range right here is between negative pi halves and pi halves, what 2 quadrants are we in? 1 and 4. Q4, Q1.
So everything except sine Q1 and 4.
Okay. So now some examples with tan. We're going to first do this one up here and this one down here. So in order for something to, yeah. Tan is y over x, right? And I'm going to draw a bootleg unit circle so that we have something to look off of. In quadrant 1, is tangent negative or positive? So I'm going to highlight this in green. In quadrant 4, is tangent negative or positive? So, like for example, this -1, are you in quadrant 1 or 4?
4.
You know you're in 4 because it's a negative value. So we're going to start here with this one. In order for something to be a fraction that equals 1, what must be true of the two numbers, y and x? They must be the same. So y and x must be the same. Now, it is a negative, so at least one of those values is going to be negative. So we know we're in Q4, but not counting positive and negative, what point on our unit circle are those two values equal to each other, y and x? Yeah, it's at the quadrant point, root 2 over 2. And I heard you say negative pi over 4. So, or 7 pi fourths. But with our with our range that we have here, we have to do the same thing that we do to the sine values, right? Where we convert them, which gives us a negative pi over 4. If I end up with an undefined value, what must be true of my value? Is the 0 on the top or the bottom? The bottom. So we have something over 0, which means our x must be equal to 0. Where on our unit circle is our x equal to 0? Where on the unit circle? What? Is that the only place where it is? Which is negative pi over 2. So in this case, we actually have two values that are valid. I'm moving down here. Okay. At pi thirds, what is my coordinate point, David? Yeah, at pi thirds. Go to your unit circle. What is my coordinate pair? Yay! So, Natalie, can you tell me what the tangent would be here? Not like simplifying it, just like what what coordinate would go over what coordinate. So, you could do this by keep, change, flip, or whatever you want. You know, I just like to cancel out my 2's. So you end up with a square root of 3. That is one option you can get. At pi over 4, you have a root 2. So my tangent, 1. And at pi 6, we flip our coordinates. So we have a root 3 over 2 for the x value. So our tangent our possible tangent values are root 3 over 3, 1, 0, and undefined. Those are the only ones that tangent can equal, right? I mean, you have your positive and your negative version of it. But I would highly suggest at pi thirds and negative pi thirds, right next to your coordinate pair, writing the tangent value equal to root 3. At pi fourths, writing in your tangent value will always be equal to 1 or negative 1. What? Scroll down. I thought you said slow down. At pi 6, writing root 3 over 3. And then between 0, pi halves, and negative pi halves, figuring out which one is 0 and which ones are undefined based on y over x. Does this make better sense than when we were trying to work backwards?
Yes.
Is everyone good if I move up? So now, if I have negative root 3 over 3, what do I have? Or which quadrant, first of all, am I in? 1 or 4? 4. So, using what we just wrote down, where is it root 3 over 3? What does the arctan mean? It's the same thing. So if I have a root 3 over 3, where am I at? Ta-da! Easy as that. So now going back to this one, you now need to complete these boxed ones 4, 5, and 8. None of them will be no solution. If you end up with the same answer for all of them, I wouldn't be surprised. But you need to know how to get there. Go where? I'll bring it over to you.
You got one more. Just art 10.
Well, you guys didn't say anything.
Art 10.
This one? Is it down here that you need? Or which one is it?
At the top. It was this one. Art 10. Let me just take a picture. Thank you.
4, 5, 8.
Can I help at all? Here? So without like these type of functions, does it make sense going to the unit circle and finding the inverse? Okay. So that's what the inverse means, because typically they give us a radian value and we have to spit out a coordinate value, but now they're giving us coordinate values, right? And our answer will be the radian values. The biggest difference is that the radian values are going to be within this new restricted domain. Look, you're cooking over here.
Yeah, you know, they were hating on me, so I had to show up.
Yeah. What'd you end up getting? Yes. So that's your new, I think you're trying to do more than one step at once. So what is the tangent of pi over 4? Yeah. So it's 1. So it would be cosine or inverse cosine of 1. How are you doing over here?
Well, it's kind of just like we're hoping for the best when I do it.
What do you mean hope for the best?
Here's what I did. So I got confused on 4 and 5. So I just skipped to 8. So I went to tangent pi over 4.
Yep.
And it's 1.
Yep.
And you put in cosine 1.
And where is the cosine 1?
Cosine 1 is at 0, right? So it's 0. Oh my gosh. Okay, wait.
Augustine, how you doing back there?
So this one, I said that cosine 0
So you didn't.
Yeah.
Yeah.
Wait, that's right?
Put tan inverse of 0. And then figure out where the tan inverse is 0. Yes, sir.
I'm confused, especially.
Tangent of 0. So at pi fourths, tangent is what? So tangent pi of 4 is 1. So you replace all of that with 1. So you still have a cosine inverse of 1. And then you have to figure out where on the unit circle those 1
is that?
appear in the x-axis. Okay, we're gonna get a move on here. So, starting with number 5, Eric, it's the inverse tangent. So where on my unit circle is the inverse tangent equal to 0? What radian value? If tangent is y over x. One more.
There's one more.
There's what's
0?
Yeah. That was great. So you replace the entire inside with 0. So the sign of 0 is what? 0. Mensa. At 3 pi halves, what is my cosine value? 0. Jaden Wood. Where on my unit circle is the inverse tangent equal to 0? It's almost like I asked you that because I thought it was a great question.
This,
The top of what? The tangent, the inverse tangent of 0. Where on my unit circle, what radian value would give me a inverse tangent of 0?
What's the radian value? Pi over 2.
Try again. That would be if it was x over y. Tangent is y over x.
3 pi over 2.
Try one more time.
What else is it?
It's 0. That was painful. Okay, Sanaya. What is the tangent of pi force? So at pi force, what is the tangent? So you replace the entire inside function with 1. Osmo.
0.
It's 0! Yay! It's almost like I said all those answers would be the exact same. That's crazy. Okay, now for some real fun. It's pretest time!